Good afternoon, students. How are you all? Welcome to one more fabulous session from Infinite Learn. I am Suresh, Faculty of Chemistry from Infinite Learn by Sri Chaitanya. Good afternoon, everybody. How are you all? Very good. Nice. Me. Thank you. Fine. Yes, welcome to the marathon sessions of NEET STEP UP 2025 program. In this NEET STEP UP 2025 program, we are conducting the sessions right from afternoon 12 o'clock to evening 6 o'clock. Both physics, chemistry and biology are going to be taught according to the NEET syllabus. So my dear students, please join in these sessions on a regular basis. If you are not able to join in these sessions according to your schedule is not permitted, you please watch the recording and rate the sessions and like, share and subscribe to the NEET STEP UP 2025 channel. How are you all? Ishita, good afternoon. How are you doing? Nice, thank you. Samdak, how are you? Nice gathering, great. So, kal kya padha ma'am? So, in a week, we are going to discuss Monday, Tuesday, Wednesday, 11th standard syllabus and Thursday, Friday, Saturday, we are going to discuss about 12th standard syllabus. यही है हमारा curriculum. ये करिकुलम में पूरा सारा के सारा नीट केमिस्ट्री कवर होना चाहिए सो दैट यू प्लीज फॉलो दीज लेसन्स एंड सेशंस एंड अकॉर्डिंग टू वर्क आल्सो वी आर डूइंग on par with the syllabus within the live session. So my dear students, you please follow these lessons and definitely if you follow these lessons, definitely you will be getting a good score in NEET STEP UP 2025 and also you will be a topper in that, right? Samdak. Very good. Hey, there was a student called Uttam, always use this right punch. So you are there now, right? Very good. So today's topic of interest is going to be aromaticity. So in the course of hydrocarbons, we completed alkane, alkene and alkyne. Now we are going into the arenes. In the arenes, first we will talk about aromatic hydrocarbons. Before that, we see what is aromaticity. Once we complete the aromatic hydrocarbons, we eventually step into haloalkanes and haloarenes. So by default, if you say this is a double tracked chemistry lessons, a track is going to be completely dedicated to organic sessions, another track is going to be the physical and inorganic sessions. TK, are you all with me? Right? Let's start. So these sessions, smell of aromaticity. Why we said a smell of aromaticity, the title of the session. So aromatic compounds, you see, aromatic compounds do have a characteristic aroma. Aroma means a characteristic smell. If you close your eyes, I just got a cup of coffee and kept in front of you. You can simply closing your eyes, you can say it's a coffee, right? So the smell, the pleasant smell coming from the coffee can tell you. So coffee contains caffeine. This caffeine has that particular characteristic smell. All aromatic compounds do have a characteristic smell. That smell may be pleasant or some unpleasant, it should be a characteristic smell, right? So we can say all aromatic compounds has some kind of aroma. That's the reason why we can say a smell of aromaticity. So do you like the title, Ishita? You like the title? Yes, there are many students, hundreds of students are seen, but a few students are participating in chat box beta. So har bachcho, please give me a fiery emoji in the session so that we can go ahead. So आज का क्लास में हमारा एजेंडा है क्या? ओके, हम पेश रहा हूँ आपका what you learn in today's session here, right? So we are going to learn aromaticity, conditions for aromaticity and aromaticity, non-aromatic, anti-aromatic and aromatic, characteristics of aromatic compounds and Huckel's rule, and we will discuss about benzenoid and non-benzenoid aromatic systems and the conditions that anti-aromatic and non-aromatic and stability of aromatic, non-aromatic and anti-aromatic and their conditions. And you have one more typical terminology, quasi-aromatic BM. So you didn't see this quasi-aromatic in your NCERT textbook, but हमारा क्लास में आपको पता चलेगा ये aromatic and quasi-aromatic है क्या. Okay, get ready what you learn here, and also will eventually fall into the benzene finally, and preparation of benzene also. Now in the chat box, my dear students, Telegram channel is given, so you please join in this Telegram channel so that you will be getting updates about upcoming sessions and NEET updates. So read NEET होगा, okay, NEET का score add करना है, revaluation करना है, सब अपडेट्स टेलीग्राम चैनल में हम प्राइवेट का आपको भेज दूंगा, ठीक है. सो इन द लाइव सेशंस आई एम नॉट गोइंग टू डिस्कस एनीथिंग. ऑफ कोर्स प्लीज हिट लाइक, share and subscribe as usual, as routine. I am going to announce you guys, right? Let's get ready in that, my dear students. So aromaticity. So reactions of alkene, see, this is a cyclohexene, this cyclohexene is an alkene. ये जैसे alkene, अगर cold KMNO for alkaline medium, this is what you call it as a Bayer's reagent. याद है Bayer's reagent. ये Bayer's reagent का कलर क्या, ये पिंक कलर वाला है. ओके, आपका चाहिए पिंक, यहाँ पर पिंक नहीं है, so it is pink in color. So it is going to hydroxylate this double bond. You are going to get a vicinal diol. Cyclohexane 1,2 diol is formed. So as a result of KMNO4 is going to be reduced itself, so it gives MnO2. So of course the pink color is there as long as KMNO4 is there, but KMNO4 is going to discharge its color. So this decolorization of the Bayer's reagent, so the addition of cold KMNO4 Bayer's reagent cyclohexane results in the breakage of this pi bond. This is your pi bond, है ना, and formation of diol. This is your diol. Are you getting or not? Right. This pink color is decolorized. So this reaction happened like this. This indicates, so pink color is decolorized, discharged. This is true जब alkene कर सकते हैं, alkyne भी कर सकते हैं. So जहां पर unsaturation है वहां पर Bayer's reagent decolorize हो रहे हैं, है ना. So but if you talk, so this test is called Bayer's test. This test is called Bayer's test. This Bayer's test is given by all unsaturated, you can say all alkenes, and alkynes. Why they have pi bond here? Why they have pi bond here, right? So this is the chemistry behind alkene and alkyne. You can see जब alkyne भी ऐसे कर रहे हैं, alkyne, when alkyne is added with cold KMNO4, you are going to get a diol, so that the product is dehydrated to give rise like this. Here addition of Bayer's reagent to benzene, it's a key point. I just want to say, my dear students, alkene react with Bayer's reagent, reason is pi bond है उसमें, alkene में pi bond के वजह से Bayer's reagent decolorization हो रहे हैं. alkyne में दो pi bond है, दो pi bond के वजह से Bayer's reagent decolorize हो रहे हैं. but जब benzene का देखना, so on the other hand benzene does not, ये क्या, benzene however it has three multiple bonds in it. So benzene का structure ऐसे देखो, benzene, this has structure like this, three multiple bonds are there, three double bonds are there. If you want to add Bayer's reagent, so आगे क्या होगा? कुछ नहीं होगा. So that no reaction. Despite of 3 double bonds in benzene, benzene is not behaving like an alkene. This is a big question mark. This is a big question mark. That's the reason why benzene is not reacting with a Bayer's reagent. इसका supernatural power है इसके साथ. ये क्या? Because of its resonance, you see the pi bond is not available addition करने के लिए. So that benzene में जो double bond है ना, ये घूमता रहता है. So that it gives a different structure. यहाँ पे भी. So it gives a delocalized pi electron system. So due to presence of delocalized pi electron system, ख्याल में रखना, ये technical term is very important. Okay, due to delocalization of the pi electron, delocalization, I already mentioned what is delocalization, resonance. Okay, due to resonance, this pi electron is completely dislocated above and below the plane of the ring of the benzene. So, however, it has a 3 multiple bonds in it, it is not behaving like an alkene. So, in the ring, the electrons are continuously revolve in a circular path. So, circular path, so total hybrid of the resonance of the benzene is given like this. So, as a result, so this is delocalized pi electron system. Due to delocalized pi electron system, it is not undergoing addition reaction, rather it undergoing substitution reaction. Okay, this is true not only for benzene, for any aromatic compounds. So, in the direction of the ring current, so diaprotic and paratropic, diatropic, these are technical terms that we use in the quantum mechanics here. In the chemical bonding, I will discuss it. So, if the delocalization is diatropic, the molecule is going to be aromatic, and if it is a paratropic, it is going to be anti-aromatic. That is not a matter. Okay, let's talk about Kekule structure. It was given in 1865. Kekule, he was a scientist. He thought during his dream, when he was sleeping, he got a dream. In that dream, he found a snake is swallowing its own tail. Based on that, he got the structure like it's a cyclic structure बना. So benzene का cyclic structure जो है, ये cyclic structure ऐसा होगा. So I just want to give you the carbon in the benzene undergo sp2 hybridization. sp2 hybridization का मतलब क्या? Carbon has 3 hybrid orbitals like this, like this, like this, है ना? और एक carbon है. So this is going to form a 3 hybrid orbitals, this is going to form 3 hybrid orbitals, and this is going to form 3 hybrid orbitals. Like that it goes with 3 hybrid orbitals like this, right? So in sp2 hybridized carbon, you just see carbon 1, 2, 3 bonds. It's a cyclic, it's a planar triangular structure. So in this planar triangular structure, so this is a planar triangular structure. Ishita, are you able to understand? So above the plane and below the plane, there is a unhybridized pure p orbital. So that unhybridized pure p orbital हर कार्बन का ऊपर होगा, है ना? Right? है ना? Right? Right? Like this. Like this. So like this. This is a parallel p orbital cyclically present on the benzene. That's great. So actually what is happening here, there is a carbon here, right? Look at this. This system I just want to write carbon, 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 carbon. Carefully you see how the benzene structure at orbital level it is given. There are 6 carbons, right? So अगर ये 2 p ऑर्बिटल्स का बीच में एक साइड बाय साइड ओवरलैपिंग हो तो यहाँ पर एक बॉन्ड लग जाएगा, है ना, राइट? यहाँ पर भी हो सकते हैं, राइट? यहाँ पर भी हो सकते हैं. सो दिस इज योर बेंजीन स्ट्रक्चर. सो आपका हाइड्रोजन जो है, सो इट इज गोइंग टू फॉर्म हाइड्रोजन हियर, हाइड्रोजन हियर, hydrogen here. This is the actual structure of benzene. It's a cyclic planar structure, right? Very good, Ishita. Hey, fine, that's clear, fantastic, that's clear. So because of this pi electron can be joined here also, so that और दूसरा structure भी बना सकता है ना? So this is the structure actually explained by Kekule, August Kekule, right? So Kekule structure depicted the benzene ring as a flat molecule. Flat means planar molecule, having an alternative single bonds and a double bonds between the carbon atoms. Alternative single bond and a double bond, single bond, double bond. So however, his original structure would have been a irregular hexagon with a different bond lengths, but later resonance concept has come, made all carbon atoms length is same. I want to say all aromatic compounds are cyclic structures. So the carbon to carbon bond length जो है cycle में हर carbon atom का length बराबर होना चाहिए. That is the essential condition for the aromaticity. My dear students, hope you are all understand, right? Any doubt? बाकी बच्चों who is there, right? Come on, that's good. Ishita. Okay, right. Today Nihal is not there in the class. Okay, right. Ravinder Reddy, no doubt, that's good. Ravinder Reddy, I think he is school is reopening today. Yesterday he informed me. What about Farhan? Okay, right. Come on. So let's see benzene derivatives. So many benzene derivatives are there in the chemistry. So the common name for the benzene derivatives, benzene and its derivatives. So who is that spirited guy? अरे आपका शुभ नाम क्या? Spirited guy? What's your name? This is your fluorobenzene. So we write benzene like this, and a fluorine is attached. So it is a fluorobenzene, right? And a chlorobenzene, we have iodobenzene, bromobenzene, chlorobenzene. Okay, many are there. Toluene or methylbenzene. Methylbenzene is also called as toluene or toluene, right? And cumene, isopropyl benzene is called cumene. कहीं देखा है क्या क्यूमीन का? मैं कल रात से ढूंढ रहा हूं, कहीं देखा है क्या? Okay, I missed it in my supermarket. Cumene is called isopropyl benzene. Okay, Muzdabin, right? Rafin Muzdabin, good name. Okay, right. Cumene, this cumene comes in phenols chapter, grade 12 NCERT textbook, alcohols, phenols, ethers. There in the preparation of phenols we use cumene hydroperoxide method. In the cumene hydroperoxide method we use cumene as a source. So world's largest phenol is prepared from cumene hydroperoxide method. So this is the importance of this cumene, right beta? Okay, all right. So let's talk about one more. This is styrene. Vinyl benzene is called styrene. So this is your styrene. कहीं देखा है क्या? Right? This is styrene. This is a styrene. This you come across in polymer chemistry. Polymers, polystyrene. Polystyrene. So this is the ingredient present as a monomer. Polystyrene, where it is used? polystyrene is where is used? You all watch TV now? The total TV cabinet, LCD panel, okay, and this remote control, the remote control is made up of special type of plastic, that is styrene. Okay, very good. And use a switch na? Switches are made with styrene. Okay, right. Xylene. Dimethyl benzene is called xylene. So this is your toluene. This is your toluene, and here it is orthoxylene, orthoxylene, metaxylene. You can also use like this metaxylene, and it is paraxylene. This is your paraxylene. These are all the aromatic compounds which has benzene as a ring in it, so it is called benzenoid aromatic compounds. Hare beta, this is orthoxylene. See, this xylene is used as a liquid to clean the lens in the camera, right? So optical instruments also cleaned by using this xylene only. Okay, coming to next, phenol. OH group is attached to benzene is called phenol. So these structures are very important, my dear students. Actually, students mislead with these structures. Sometimes you are getting a structure like this. Organic chemistry का simple method होते हैं, structures अच्छा तरफ सीखो. What do you call this? Raffin, what do you call this? This is benzyl alcohol. This is benzyl alcohol. ठीक है? And this is your phenol. OH group जब बेंजीन को डायरेक्टली लगा होता है ना, that is called phenolic group. Okay? उसका different group भी लगा सकते हैं. They are all called as phenols. Talking about benzoic acid. So let's talk about benzoic acid. Benzoic acid is this. जब carboxylic acid directly attached to benzene is called benzoic acid. Are you getting or not? So silent sitting in the class quietly is an offense. You just keep on talk to me, right beta? Very good. And it is not a radio transmission beta, it is a live session. So live session is a two-way transaction, so there should be an interaction between you and me. Okay, yes, benzyl alcohol. Okay, now very good. Raffin, could you say the name of the molecule of this structure? Okay, CH2 COOH when it is with benzene. Raffin, answer bolna. You want to know the answer? Very good. Come on, somebody. Raffin, Ishita, or any students? Other students, come on. अरे कम से कम कुछ आंसर देना यार. I am waiting for your answer. So this carboxylic acid is not directly attached to the benzene, so it is not aromatic carboxylic acid, it is aliphatic carboxylic acid. इसका नाम क्या होगा? It is phenyl acetic acid, phenyl ethanoic acid. This is phenyl ethanoic acid. याद है बेटा? Right? You all know these structures. So कम से कम याद रखना पड़ता है. Benzaldehyde, you can say it is a benzaldehyde. इसका भी ये structure ऐसा लिख सकते हैं. So structure यहाँ पे लिख सकते हैं. ये printed version है, ये written version है बेटा. Very good. And acetophenone. Acetophenone. This is the structure acetophenone like this. Where do you see? फ्रीडल क्राफ्ट एसाइलेशन का पहला एग्जाम्पल है. एसिटोफिनोन, एसिटोफिनोन। आपका बेंजोफिनोन स्ट्रक्चर कैसे होगा? आपका बेंजोफिनोन का स्ट्रक्चर कैसे होगा? किसी को पता है? मैं बोलना है क्या? चिल्ड्रन, बेंजोफिनोन का स्ट्रक्चर, सो बेंजोफिनोन का स्ट्रक्चर होता है ऐसे, सो इट इज गोइंग टू बी लाइक दिस। वेरी गुड, दिस इज बेंजोफिनोन। Why I am giving this emphasis on the simple names in this session? Why? Because in the NEET examination, my dear students, you will be asked a question from a name to another name. पहला ये नाम का स्ट्रक्चर क्या आपको पता होना चाहिए, then only you can understand कौन सा कॉन्सेप्ट इस्तेमाल करके ये क्वेश्चन करना. So benzene is converted to benzophenone. Okay, what is the reagent you use? So benzene structure पता है, बेंजोफिनोन का स्ट्रक्चर, सो दैट इज द बेंजोफिनोन का स्ट्रक्चर. और एसिटोफिनोन का स्ट्रक्चर, क्या क्या रिएजेंट्स इस्तेमाल कर सकते हैं? यस इशिता, यू सेड इज करेक्ट. ओके, वेरी गुड. लेट्स टॉक अबाउट, आगे बढ़ना. सो मिथाइल बेंजोएट. देखो बेटा, आई एम गिविंग ए ट्रेनिंग इन दिस सेशन. देखो एसिटोफिनोन का स्ट्रक्चर याद रखो पहले. अभी तो है methyl benzoate. This is C double bond O CH3, and this is the structure. This is the structure. Now you see the last structure and the first structure. दोनों बराबर देखने के देखना, बट अलग स्ट्रक्चर का है. देखो फिर भी ये एसिटोफिनोन का है, methyl benzoate is an ester. It's an ester, right? It's a ketone. Understand? It's a ketone. It's an ester, right? Anisole. Where do you see this anisole, beta? Anisole. Where do you see this anisole? Alcohols, phenols, ethers. In the ethers, at last, the reactions are given in NCERT part 2 chemistry textbook. Okay. So anisole, methoxybenzene is called anisole. This is your methoxybenzene. Fine beta. And nitrobenzene, nitrobenzene. This nitrobenzene स्ट्रक्चर ऐसे है. इसका जो इसका बाय है कौन है? aniline. Aniline. Who is aniline? This benzene with NH2 is called aniline. So many students confuses with aniline and nitrobenzene. Amino group है, nitro group है. इसी तरह pH NH2, correct. Capital N, capital H. Okay, benzonitrile or cyanobenzene. Cyanobenzene is this one. Okay. So this is the structure, can be written like this also. Are you getting or not, my dear students? Any doubts? Okay, very good, very good. Okay, next. Benzene derivatives in the organic chemistry. Benzamide. This is called benzamide. CONH2. Okay, you can also say CONH2 like this. This is your benzamide. So when you see the structure, if the structure is shown like this, if the structure is shown like, you don't have to worry, इसका असली structure क्या है पता होना है. So benzene sulfonic acid, yes, O3H. This is your benzene sulfonic acid. I am telling you, you may study chemistry in high standards, depth of the subject. इसका कुछ फर्क नहीं पड़ता है, कुछ फायदा नहीं होता है. लेकिन आपका जो स्ट्रक्चर्स है, जो फंडामेंटल्स है, अच्छा तरीका अभ्यास करो, अच्छा तरीका लिखने का चांसेस बहुत अच्छा होगा, है ना बेटा? राइट. सो दिस इज योर naphthalene, this is your anthracene. So we use naphthalene in urinals, in the public toilets. That balls we use, white color balls you use, that is naphthalene balls. And this is your anthracene. You can use anthracene structure like this. So this is your anthracene structure. Okay, you can see phenanthrene. So these are all benzene related aromatic compounds. So these are called benzenoid aromatic compounds, where again I will come back with this aromatic benzenoid and non-benzenoidic tariqa. So आगे बढ़ना है, non-benzenoid aromatic compounds है. So उसमें जो बेंजीन होना चाहिए benzenoid aromatic compounds है. So non-benzenoid aromatic उसमें तो बेंजीन है, बेंजीन है, बेंजीन है, बेंजीन है ना. So non-benzenoid aromatic में without benzene they have a different structures. So benzene का जैसे होते हैं, but they are not benzene related structures. So they are called non-benzenoid structures. Fine beta. So non-benzenoid compounds are the organic molecular species either with all carbon atoms in the cycle with one or more heteroatoms. Heteroatoms like nitrogen, oxygen, sulfur should be present as one of the atoms in the cyclic system. They are called non-benzenoid aromatic compounds. So compound which exhibit aromatic behavior but does not contain any benzene molecule. So this is an important point. They are called non-benzenoid, right? So NRI के जैसे non-resident Indian. So they are Indian but non-resident. I say. So they are aromatic but they don't have benzene. NRI quota, right? So the most basic example of non-benzenoid aromatic compounds is azulene. Is a system of two fused rings. One is 7, another one 5. 7 plus 5. Okay, इसका स्ट्रक्चर ऐसा होता है. azulene इसको बेंजीन का जैसे देखते हैं, लेकिन बेंजीन नहीं है. बेंजीन में कितना कार्बन एटम है चार्ट बॉक्स में बोलो? 6 कार्बन एटम का. लेकिन इसका कितना कार्बन एटम देख रहे हैं एक रिंग में? 1 2 3 4 5 6 फिर 7. There are 7 carbon atoms in one ring. And दूसरा रिंग में कितना देख रहे हैं इशिता? फिर भी 1 2 3 4 5. So this is not at all related to benzene but it is aromatic. How it is aromatic we will discuss it. This structure ख्याल में रखो, ये azulene होगा. azulene, ठीक है? ट्रोपोन. सो ट्रोपोन कितना कार्बन एटम्स है उसमें? 1 2 3 4 5 6 7 like that, है ना? Right. Any doubt here? Any doubt here? And also I have non-benzenoid, दूसरा में 5. Yes, exactly. Non-benzenoid heterocyclic systems का एक एग्जाम्पल देना चाहता हूँ. These are all the confusing but ख्याल में रखने का जरूरत है. लेकिन see here pyrrole, you see this pyrrole structure in the nucleic acid, उसमें नाइट्रोजन है, फ्यूरॉन ऑक्सीजन है. सो जो लोन पेयर है ना ये याद रखना. ओके, राइट. नाउ thiopene sulfur containing heterocyclic aromatic and imidazole pyridine and pyrimidine nucleic acids में होगा. Indole. So these are all the structures we see, very important, and especially for the you need people study biology also. In that biochemistry is there, biomolecules are there, these rings are important. DNA and RNA you will be getting all these things. So you please take a snapshot of it. 3 2 1 एक बार खींचना. Right. Now, can we go ahead? Ishita, come on. Come on. Okay, right. So, classification of organic compounds, cyclic compounds. So, classification of cyclic organic compounds, there are 3 types. aromatic compounds, anti-aromatic compounds, non-aromatic compounds. There are three categories of compounds. In these three categories of compound, let's talk about conditions. So let us talk about aromatic. ये compound aromatic बोलने के लिए conditions क्या? ये compound aromatic बोलने के लिए conditions क्या? Let's talk about conditions for aromatic. So simple thing, four important tricks I just want to give you. So एक ही स्लाइड में देना चाहता हूँ. ये ट्रिक सीधा इस्तेमाल करो बेटा. सो आपका पता चलेगा जो कंपाउंड एरोमेटिक होगा ना, ये एरोमेटिक होगा. एरोमेटिक होगा तो एरोमेटिक बोलो, अगर ना एरोमेटिक होना तो नॉन एरोमेटिक बोलना है. ठीक है बेटा. सो यू कैन इंप्रूव योर स्कोर if you follow these lectures. My dear students, for improvement to program there should be a plan. So ये प्लान अच्छा तरफ हमारा तरफ से एक ऑर्गेनाइजेशन करना चाहता हूँ. सो आपका जो गूगल फॉर्म्स का लिंक दिया, so you please fill this link and you can join in that, so that we are going to track your performance as well and we will get set ready for your preparation. Okay, तन्नू गुड आफ्टरनून. कल आए थे ना क्लास का? हाँ. ओके, लेट्स टॉक अबाउट conditions for aromatic. So the पहला जो condition, there should be a complete ring. A ring, it should be a cyclic structure. Okay, that is the first point. That's the first point. And the ring must be planar and no atom of the ring must be sp3 hybridized. Right? And if lone pair or negative charge is there, you please don't worry about hybridization is the criteria. Agar every atom should be, I just want to say every atom should be sp2 in the ring. That's very important. So sp2 is a planar structure. If the ring is made with only sp2, a plane connected with a plane, connected with a plane, connected with a plane, पूरा ring planar हो जाना. Right beta? Now you want to say if a lone pair of electron is there or if negative charge is there, if the lone pair of electron is participating in delocalization, planarity देखने के लिए hybridization condition इस्तेमाल करना इतना important नहीं है. Okay, the system is going to be automatically planar hoga. Okay, and yes, I am going to explain you that. Okay, and it must be fully cyclic conjugated. I mean to say here the resonance should be present in the complete ring. So I just want to say resonance is completely present in the ring. So the resonant should be present in complete in the ring completely. आपका जो बेंजीन है ना, so here and the resonance is happening like this, so that you should have complete delocalization like this. The resonance should continue throughout the ring. That is the meaning of the point 3. Right, Ishita? Fine. And it must follow Huckel's rule. Kekule is different, Huckel is different. Kekule given the structure of benzene. Huckel has given empirical formula to pick the aromaticity. Okay. So, a Huckel rule kya? The total number of delocalized pi electrons should be 4n plus 2. So 4n plus 2 number of pi electrons. So you remember like this. If you read this like this, na, you will get confused. 4n plus 2 is equal number of pi electrons. Okay. यहाँ पर कितना pi electrons देख रहे हैं? Number of pi electrons that are being involved in the conjugation. So my dear students, here ये bond है ना, bond means 2 electrons है. ये बॉन्ड है ना, बॉन्ड मीन्स 2 इलेक्ट्रॉन्स है, ये बॉन्ड है ना, बॉन्ड मीन्स 2 इलेक्ट्रॉन्स है. सो 2 2 2 कितने इलेक्ट्रॉन्स है? 6 इलेक्ट्रॉन्स है. अभी 4n प्लस 2 इज इक्वल टू बेंजीन में 6 इलेक्ट्रॉन. अगर ये इक्वेशन सॉल्व करने तो आपका n कितना आ रहा है बेटा? 1 is coming. If an integer is coming, the compound should be aromatic. On solve this, you solve this for any structure. Okay, solve for n. So everybody knows Huckel rule, but Huckel rule कैसे इस्तेमाल करना ये नहीं पता है. So solve for n value. Okay, n value. If you get n is equal to 0, 1, 2, 3, it goes like this, an integer, then the compound is aromatic. बस 2 plus 4 plus 6 plus 10 plus 14, these are called Huckel numbers. Yeah, it could be anything. Okay, don't memorize anything. जो भी structure दिया उसमें delocalized number of electron कितने पहले देखो. 4n plus 2 is equal to number डालो, n सॉल्व करो फिर. ठीक है, that's good. So ये कंपाउंड एरोमेटिक होने के लिए फर्स्ट पॉइंट, सेकंड पॉइंट, थर्ड पॉइंट, फोर्थ पॉइंट, ये चारों पॉइंट्स it should accept, otherwise the compound cannot be aromatic. Fine. So this is about aromaticity. Let us talk about non-aromatic. Dorji, I am teaching in my studio yaar, you want to come? Dorji, Kunjang Dorji, I am teaching in my studio at Hyderabad Infinity Learn corporate office. You want to meet, you come here, right? So here I am teaching about aromaticity, about NEET examination. Talking about, chalo, next example, if n is equal to 0, then we get the following: 4n plus 2 pi is equal to 4 into 0 plus 2 is equal to 2 electrons. Therefore, the ring with 2 pi electrons is aromatic, right? Now, talking about similarly n is equal to 1 भी होगा, n is equal to 2 भी होगा, n is equal to 3 भी होगा. Benzene has a ring and all the carbon atoms are sp2 hybridized. Thus, it is a planar. पहला जो point है in the benzene. There are 3 double bonds on alternate positions, so there should be a cyclic. So alternate position conjugation is there, and the fully cyclic conjugated, that is the third point. Also there are 6 pi electrons, so that 4n plus 2 is going to be followed. Fourth point bhi hai. So first point, second point, third point, fourth point is accepted. Benzene is aromatic compound, है ना? Like that you can do it. Many examples we can do based on aromaticity. Okay, let's talk about, note, if more than 2 p orbitals are parallel, then the overlapping simultaneously, then there is a conjugation. Given one of them is filled, another one is a vacant. So if both are vacant, nahi hoga. Okay, so both should be at least one unpaired electron. If one is vacant, another should have a pair of electrons. Then only conjugation can happen. So characteristics of aromatic compounds. My dear students, they have a characteristic smell. I told you about coffee. Okay, so they are extra stable, and they burn with sooty flame. I am going to show you here a few aromatic compounds. Just we want to explain you guys. So this is an aromatic compound, oil of wintergreen. Okay, methyl salicylate. You know, whenever you have a pain, you use Volini spray, right? That is methyl salicylate. Got it? That methyl salicylate has this particular compound which is aromatic. You will get a smell. Okay? So, methyl anthranilate, grape taste. This is the compound gives grape taste, artificial flavors in the fruit juices. Okay, children. And saffrole, root beer smell. This is aromatic compound. And mescaline, europhic. So this is used in drugs and different kind of stimulating medicines and all. Okay. Of course, I said they have a characteristic smell. ये characteristic smell आपको demonstrate करने का ये slide prepare किया गया. So you need not have to learn these structures. Rather you learn the structure of vanillin and all. You have NCERT, aldehydes, ketones and carboxylic groups. In that first page it is given. And they burn sooty flame. They burn sooty flame. A sooty flame है क्या? Sooty flame means a flame with lot of smoke and lot of soot. You know, this is what you call sooty flame. When you place a lid over here, you can collect the entire smooth carbon sediment. You can scratch it. So they are going to burn with release of carbon black. That carbon black is used in the printers, printing ink. Okay, why they burn with sooty flame? When you see in the street side also, somebody is going to burn that scooter tire, car tire during the winters. Okay, they give the black smoke, है ना? That's good, that's good. Aromatic compound, उसमें carbon to hydrogen ratio ज़्यादा होता है. So high carbon to hydrogen ratio makes the compound they burn in sooty flame. So that is the meaning of a sooty flame. They are extra stable. They are extra stable. So if you take a benzene in a bottle and keep it come after 100 years, hypothetically, a benzene will be like benzene only, because benzene is aromatic extra stable. Understand, my dear students? Right. And very important point, so they do not undergo addition reactions. मैं ये बोल चुका, rather they undergo substitution reactions. So they do not undergo addition reactions, rather they undergo substitution reactions. Benzene do not react with Bayer's reagent, rather they undergo. Sri Krishna, who is Sri Krishna? Please subscribe. Sorry for disturbing. Okay, क्या बोलना चाहता हूँ? Sri Krishna, what do you want to say? What do you want to say? So you are not disturbing if you are participating in academic discussion. Okay, it's not a matter. If this is about aromatic systems, you can also listen and can make a note of it, right? Okay, Jai Krishna. Okay, so this is a very important point. They do not react with Bayer's reagent, rather they react in substitution reaction. There are 5 reactions are there for benzene: nitration, sulfonation, chlorination or halogenation, Friedel-Crafts alkylation, Friedel-Crafts acylation. 5 golden reactions. Okay, let's talk about aromatic compound burn with sooty flame, because they have the ring structure of carbon atom. This causes incomplete combustion of carbon, and it has a high carbon to hydrogen ratio. That's very important. A point note karna jarur hai. Okay, not an issue. Okay, let's talk about classification of compounds. मैं बोल चुका aromatic, anti-aromatic, non-aromatic. ये aromatic में benzenoid and non-benzenoid aromatic compounds, we already seen the structures of benzenoid and non-benzenoid structures. Okay, benzenoid aromatic system, molecules having at least one benzene in the system is known as benzenoid. You have naphthalene, anthracene and phenanthrene. उसमें नंबर ऑफ पाई बॉन्ड्स कितने हैं? 5. कैलकुलेट करके बोल सकते हैं ना इसी तरह. ओके, उसमें 7 and 7. नंबर ऑफ पाई बॉन्ड्स कितना है? नंबर ऑफ पाई बॉन्ड्स 5, नंबर ऑफ पाई इलेक्ट्रॉन्स उसमें डबल 10. 7 बॉन्ड्स 14 इलेक्ट्रॉन्स, 7 बॉन्ड्स 14 इलेक्ट्रॉन्स. सो नंबर ऑफ पाई इलेक्ट्रॉन्स पकड़ना जरूर है, क्योंकि हकल रूल ए नंबर इस्तेमाल करके हकल रूल कर सकते हैं ना, राइट. नाउ एंटी एरोमेटिक कंपाउंड, दिस इज वेरी इंपॉर्टेंट. दिस इज वेरी इंपॉर्टेंट. एंटी एरोमेटिक कंपाउंड्स आर गॉन केस because we feel they are aromatic, लेकिन aromatic नहीं है. So they got everything but they lost their passport. I mean to say aromatic बोलने के लिए हमारा तरफ 4 पॉइंट्स हैं. सो पहले जो पॉइंट है कॉमन है, दे मस्ट बी साइक्लिक. यस. ए सेकेंडरी पॉइंट दे मस्ट बी ए प्लानर, वो भी चलता. And third point, they must be fully cyclic conjugated. 3 points are common for aromatic and anti-aromatic. लेकिन ये 4 point है ना, 4, there must be 4n plus 2 electrons. So this is the 4th point. So this 4th point is very important. First 3 points are okay, and the 4th point, 4n plus 2 is not accepted. Unfortunately, if this is followed, na, this compound can also be aromatic. You can see cyclobutadiene, this structure. For example, 1,3-cyclobutadiene is a cyclic planar conjugated system. है ना? I just want to say here 4n plus 2 rule इस्तेमाल करना चाहता हूँ. So इसी तरह 4n plus 2 इज इक्वल, उसमें रेजोनेंस है, कितना पाई इलेक्ट्रॉन्स है? एक पाई बॉन्ड है, 2 इलेक्ट्रॉन, और एक पाई बॉन्ड है, 2 मोर इलेक्ट्रॉन, टोटल इज इक्वल टू 4 इलेक्ट्रॉन्स. इफ यू सॉल्व, n इज गोइंग टू बी कितना आ रहा है? n इज कमिंग टू बी 1/2. सो ये इंटीजर नहीं है, so that this fourth point is not accepted, so that is the anti-aromatic. Anti-aromatic बहुत खतरनाक है. It is highly unstable. Aromatic is highly stable, anti-aromatic is highly unstable. है ना? पूरा उल्टा के उल्टा 4th point का वजह से. We can say 4n plus 2 is not followed, or it can have only 4n pi electrons. Yes, very good. Any doubt, my dear children? Any doubt? Fine. Now, non-aromatic compounds, they are just like refugees. Okay, so they are good only, okay, but they are not aromatic. So I just want to say compounds that have neither aromatic nor aromatic characters. So you have, I just want to give you here okay, you have non-aromatic compounds, first point, second point, third point, fourth point, है ना? Cyclic and planar and conjugation resonance, and you have 4n plus 2 number of pi electrons. There are 4 rules. Harsh, ओके आपका सिस्टम हैंग हो गया। ये भी हमारा ट्रिक है बेटा, हमारा ट्रिक है, ये देखो, यू फॉलो दिस ट्रिक, सिंपल खेलने के लिए। You can do 2000 questions based on this. Cyclic system, a compound follow this point 1, point 2, point 3, point 4. जब ये बोलेगा आपका aromatic, ठीक है। If the compound is following this and following this, at last this point is not following. If that is the case, it is said to be anti-aromatic. If the compound is cyclic, okay, it could be planar or non-planar like this. You don't have to look at this. Any one of these 3 points is not followed. Any one of the first 3 points are not followed, there is no sense of following the 4th point. So, I'll come back. This is what you call it as a non-aromatic. So, you please keep this particular trick, or you can say ये खतरनाक है. You can do total aromaticity based on this particular table. Okay. So, Harsh, okay, Ishita, if anti-aromatic, then 4n pi electron, who will, oh yes, you are saying correct. But if 4n plus pi होगा तो 4n plus 2 नहीं follow कर रहे हैं ना. There is another way to memorize. Okay, anti-aromatic only not follows the 4th condition. 4th condition only is not followed. Okay, so that you said correct. You said correct. ठीक है. So this is the trick. This is the trick. And non-aromatic बोलने के लिए बेटा first 3, any one of the first 3 points is not followed, it is outside the game. So it disqualified. So point 1 or 2 or 3, any one of the point is not qualified, it is disqualified for aromaticity. So it is and non-aromatic. Okay. So this is about non-aromatic compounds. You can see these are all. The order of stability जो है, aromatic compound is more than non-aromatic compound, anti-aromatic compound. Anti-aromatic compounds are extremely unstable. Extremely unstable. If anti-aromatic compound is about to form during a reaction, the reaction आगे न बढ़ना. Okay, the reaction do not happen, right? Now, talking about based on the aromaticity, which of the following is an aromatic hydrocarbon? जल्दी बोलना फटाफट. Which of the following? You can say highly reactive, of course. Answer, I just looking at the chart box. Who will give the correct answer, my dear students? That's good. Fine. Fine. Answer B, correct. Answer B, correct. So, this is anti-aromatic. This is aromatic. And here conjugation is there, cyclic system is there. Here complete conjugation is not there. So, this is sp3. It is not planar. This molecule is not planar. This is non-aromatic. है ना बेटा? This is also non-planar. So, it is non-aromatic. Are you getting or not? So, you have to identify whether it is aromatic or non-aromatic, also anti-aromatic. है ना? Now, आगे बढ़ना है. That's good answer. So this is the explanation that is given. This is the explanation. सारे के सारा नोट्स आपको मिलेगा ये टेलीग्राम चैनल में. सो टेलीग्राम चैनल में आप ज्वाइन करना इम्पॉर्टेंट है. ओके, नाउ सो बेस्ड ऑन द aromaticity, what is the order of stability of the given compounds? Compound 1, compound 2, compound 3. 3 compounds are given. I want you to give the order of stability. ये मल्टीपल चॉइस क्वेश्चन है, आप खुद बनाना है. आई एम वेटिंग फॉर द आंसर. वेटिंग फॉर द आंसर. इशिता, स्पिरिटेड गाई. ओके, हर्ष गेमिंग, राइट. कम ऑन, कौन करना है? दैट्स गुड. 1 is greater than 3 is greater than 2. Very good. 1 then 3 then 2. Wonderful answer. बेटा ये इसका नाम क्या बोल सकते हैं? ईशिता, इसका नाम क्या? इसका नाम क्या? Phenanthrene. Phenanthrene. Okay, it is aromatic compound beta, and this is anti-aromatic compound, and this is non-aromatic compound. So that उसमें aromatic compound is always stable, then non-aromatic compound is always stable, then anti-aromatic compound is important, right? That's a wonderful answer given by the students. I appreciate it, my dear. Okay, और कुछ करना है. Okay, this is the notes. You can just pursue the notes, right? Now, why do aromatic compounds burn with sooty flame? That we already discussed, because of they have relatively high percentage of carbon. I said high carbon to, they have high carbon to हाइड्रोजन रेशियो है ना, ये डिस्कस किया. नाउ क्वाशी एरोमेटिक, एक्चुअली यू जस्ट सी, ये एक स्ट्रक्चर आपका दिया हमें. व्हाट इज द स्ट्रक्चर ऑफ दिस ट्रोपोन? ख्याल में रखो, ट्रोपोन, राइट? ट्रोपोन, you just see, let's go with the trophon here, 7-membered ring. This 7-membered ring जो है, so I just want to give you the trophon structure. Quasi-aromatic compound. Actually the term quasi-aromatic compound is not given in the NCERT, but I just want to give you the term here, quasi-aromatic compound here, trophon. This is your trophon, right? This is a neutral molecule, but there is a electronegativity difference between carbon to oxygen. Therefore what happened? Here, carefully you see, the pi bond is going to be shifted. As this pi bond is going to be shifted, you are going to get a structure like this. This structure gives negative charge over here, positive charge over here, right? Now you see the entire system is cyclic and it is a planar, sp2 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 planar, and there is a conjugation or a resonance, and you see 4n plus 2 is equal to 1 2 3 4 5 6 electrons. If you solve n is equal to 1, so मेरा ख्याल से ही फर्स्ट पॉइंट ठीक है, सेकेंड पॉइंट ठीक है, थर्ड पॉइंट ठीक है, फोर्थ पॉइंट भी ठीक चल रहा है. इसीलिए दिस इज कॉल्ड एरोमेटिक. दिस इज एरोमेटिक. So this aromaticity is appeared due to charge generation. So it always want to be in a charged state rather uncharged state. So that is called quasi-aromatic species, the best example I discussed here, right. So aromatic compound which positive or negative charge present in the ring, okay, are part of Huckel rule are known as quasi-aromatic, like trophylium ion, cyclopentadienyl anion are the best examples for this, right. Are you getting or not? Any doubt? Any doubt? Clear? Now I just want to give you some more examples. This is about quasi-aromatic. We do it and we know it, but the term quasi-aromatic is not known to the guys. That's fine. Let's talk about, so it is also cyclopropenyl carbocation is extraordinarily stable because of its quasi-aromatic, okay. So characteristics of quasi-aromatic compounds, फिर भी they are highly stable, they are soluble in polar solvents, they have high dipole moment, already charge is there now, they have high dipole moment, okay, and they have high boiling and melting point क्योंकि their polarity, melting point, boiling point is always directly proportional to the charge or the polarity, right, my dear students. Based on the system, out of the compound which is more stable, ABA. So trophylium carbocation is more stable than benzyl carbocation. Because of the trophylium carbocation, it acquires aromaticity, but it is already aromatic. This carbocation जो part है, this is not part of aromatic. So the other part may be aromatic. Here the carbocation part is a part of aromatic. So it is more stable. Trophylium carbocation is more stable than benzene. बेंजाइल कार्बोकैटायन में सिर्फ रेजोनेंस चल रहा था बेटा, लेकिन ट्रोफाइलियम कार्बोकैटायन में आपका रेजोनेंस भी होता है ना, रेजोनेंस भी होता है, एरोमेटिसिटी भी होता है. नाउ out of these two compounds which is more stable, cyclopentadienyl carbanion is extremely stable because of the aromaticity. This lone pair of electron is in resonance. So it follows 4n plus 2 is going to be 6 electron. इसका 4n plus 2 is equal to 6 electrons है ना. If we solve n is equal to 1, यहाँ पर this is in just resonance, okay, is not a part of aromaticity. So like this you need to understand the aromaticity का importance होता है क्या. So I just want to discuss so many things here in today's class, but I just force it to end up this today's class. और एक चीज़ है, हाँ, could you tell me the name of the molecule here, entire class? What is the name? Shivam, hello. Shivam, come on. You just make an interaction now. Now only how to make an interaction. What is the name of the molecule? Cyclo octatetraene. Cyclooctatetraene. Okay, this is said to be anti-aromatic, but it is not anti-aromatic, it is non-aromatic. It is a non-planar structure. This appears, it is a non-planar structure. People thought this cyclooctatetraene is a planar structure, and previously it was said to be an anti-aromatic, but it is non-aromatic because it has this structure like this. So No smabbing, no, right. So it is looks like a bathtub. So bathtub in the organic chemistry is cyclooctatetraene. So it is a non-planar structure. So it is said to be non-aromatic. People claim this is a plane, but recent studies it is observed that it is a non-planar structure. Are you getting or not, Ishita? Fine. It is like boat like, it's a bathtub like thing. You can also say it's a boat like thing, right? Okay. Anyways, we discussed it today. We discussed it today about aromaticity, non-aromatic, aromatic, anti-aromatic, and the structures of the many benzenoid and non-benzenoid structures and the stability of these, right? Aromatic is more stable than non-aromatic, is more stable than anti-aromatic. Anti-aromatic कम से कम stable है, okay? And अगले class we are going to discuss about benzene preparation and properties, okay? So we'll do the best, and tomorrow we are going to meet with more stuff about the aromatic systems. So please like the sessions, okay, and share with your friends, and you subscribe to the channel so that you will be getting updates based on this. So however, right now one more session, that's the reason why I am ending today's class 10 minutes early, okay. Hope you all understood today's session. You please, if you have any doubts, you please watch the recording. If you are not able to attend regular basis, you please watch the recording, and also you can make a comment on it so that I can reply those comments so that you will be get benefited, okay. Share this session with your friends better, okay. See you, bye bye, thank you very much.